Hi guys, today our topic would be about homogeneous differential equation, auxiliary equation, and we're gonna focus on distinct roots. So here we have our example for distinct roots. We have the quantity d cubed plus 3d squared minus 4d y is equal to 0. So in order to start the process, first we must transform it into auxiliary equation. So we have m cubed plus 3m squared minus 4m of y is equal to 0. So as what you can observe, our first term has the exponent of 3. So in order to transform it into a quadratic equation, we're gonna factor out the m. So we have m to the or multiply our m times, since we factored out 1, so we're gonna subtract 1 to the exponent. So we have m squared plus 3m minus 4. So now we could get the roots. So as what you can observe, m here is factored out, so our m sub 1 would be equal to 0. So now we can solve for the roots for this quadratic equation. So we have we're gonna find for a number that when we multiplied the number or the numbers, the two number, we're gonna find negative 4, and if we're gonna add them, we would have 3 here. So the number are it would be positive 1. It should be positive 4 and negative 1. So we have m plus 4, and then we have m minus 1. So this is our factored form from this quadratic equation. So now we're gonna equate it to 0. So m plus 4 is equal to 0. So in order to get the value of m, we're gonna transpose it to the other side, so that, and it would change the sign. So we have m is equal to negative 4. So the other one, m minus 1 is equal to 0. So in order to find the value of m here, we're gonna do as what we did here. So we have m is equal to 1. So now we already have the m sub 1, so this would be our m sub 2 and then m sub 3. So now we already have the value of the m here. So in distinct roots, we're gonna use in order to get to have the answer, we're gonna follow the right equation or right form of equation. So the form for distinct roots, we have y is equal to c sub 1 e to the power of, this should be our m sub 1 x, and then plus c sub 2 e to the power of m sub 2x plus so on. So we're just gonna add 1 here, so on. So we have m sub 1 times x, so here we have m sub 2x, so the next one would be m sub 3, and so on. So now, as what you can observe, we have 3 values for m. So this would be y is equal to, we have c sub 1 e, our m sub 1 is 0, so we have 0 multiplied by x, then we have plus c sub 2 e to the power of, our m sub 2 is negative 4, so this will be negative 4 times x, plus we have m sub 3, so this would be c sub 3, and we have e to the power of, we have 1 multiplied by x. So now we're gonna solve for the answer. So y is equal to, as what you can observe, we have 0 here, so this would gonna cancel and we're gonna leave with 1, so this would be c sub 1 plus, here we have negative 4 times x, so that would be negative 4x, so we have c sub 2 e to the power of negative 4x, then c sub 3 e to the power of 1 times x, or simply just put x. So this would be this is our solution for the auxiliary equation in distinct roots for this equation.